Hello, Jake here, and this is the feather data node from PlumeFx version 2. This node has everything you need to make realistic feathers fast and reliably. The biggest addition compared to version 1 is Viewport Controls. You can set the number of control handles you want for each feather in the Handles section. Most feathers only need 5. You can select a handle and a gizmo will appear. You can select multiple handles. You can think of the handles as curve control points, as the barbs are generated with the same logic as a Bezier curve. You can turn mirroring on or off whenever you need, and you can use a scroll wheel to change the scale of each handle. You can get good general feather shapes with these controls, but for finer detail, my node relies on adding random noise, which we'll get to later. On the node parameters, you can give each feather its own color and group ID. The colors will be used for visualization later. You can choose which parts of the feather you want to generate in this toggle row. The feather data node is also used to populate the feathers, so some parameters won't do much until a guide groom is plugged in. The stem controls are quite simple for now. I have plans to add cross-section controls later. The stem divisions can be manually set, or dynamic based on feather length, with a multiplier. You can have a static amount of barb divisions, or have them divide dynamically based on barb length. This can add detail where needed, and save data where it's not needed. The shortest barb will be set to min divisions, and the longest barb will be set to max divisions, with a bias control. The number of barbs can also be static or dynamic, and will be based on feather length if dynamic. You can see this if we plug in some guides and turn on dynamic barb count. You can see the amount of barbs per feather is relative to the feather's size. This can be adjusted. Barb div by count will reduce the barb divisions based on length. The smallest feather has much less geometry than the longest feather. The barb Y bias will add a bias to the location of the barbs along the stem. The barb width can be controlled on the X and Y axis of the feather. The barb width is also relative to the distance between the barbs. Every good feather system needs a way to make barbules. In PlumeFx, I opted to make barbule cards that you can apply a tiled texture to in the shader. That way you can have barbules on the whole groom. The barbule width is also relative to the distance between barbs. The noise section is the most important for making a good-looking feather. As you can see, the noise breaks up the shape of the feather and adds detail. Random length will help break up the edge of the feather a little bit. Random lerp will randomize the division location of the barbs, which doesn't do much with dynamic barb divisions. The down noise is a bit more in-depth. You can use the down attribute for visualization. Here I make the noise scale at 0 to help. Down region will move the down along the y-axis of the feather. Down blur barbs will change the ramp up along the barbs. And down blur stem will change the ramp up along the stem. Down bend will bend the barbs to the back of the feather so they don't stick out of the groom. And down grow will add extra length to the down. If we go back to the barbules, you can see the barbule down multiplier can make the downy barbules thicker. You can also use the down attribute to make the downy barbules a different texture. The wave noise is used to break up the shape of the feathers nicely. You can use the frizz noise to add a little bit of randomness to the tips of the barbs. I kept the parting controls very simple, just probability, scale, and region. The feather damage is a fun one. It is often overlooked, but some feathers take quite a bit of punishment, especially tail feathers. Now that the feather is nice and noisy, we can move on to some technical stuff. Each feather needs a proxy to be ran through simulations. The PlumeFx proxy is very specialized to create good geo for Vellum or other solvers. The proxy match option runs the proxy through a deformer to match it exactly with the full feather, which is very important to get good results after a sim. You can see how closely the proxy matches the full feather, and how it follows the shape of the wave. The proxy resolution is tied to the barb count, with a scaler to get more or less geo if needed. The proxy generation will ignore all downy barbs. Proxy X bias can move some loops closer to the edge of the feather, since that is sometimes where the most geo is needed. The proxy has some attributes added for the simulation. You can edit the attachment and stiffness along the X and Y axis. In the shading section, you can enable dual-sided shading. This will make a copy of the barbs and offset them by a split distance. Each side will get its own side value. This can be used to shade each side of the feather a different color. Each part of the feather can have its own shader assigned here. Feather data will generate attributes that are used by other PlumeFx nodes or for shading, like Barb ID, Down, Feather ID, Group ID, Width for the barb curves, and the overall length of the feather. Rest P is the rest position of the feather, so at any time downstream, you can put the feather back to its rest position. The rest position does not include any noise. There are a few UV attributes that can be used for shading. PUV is a projection UV. FUV is a UV along the stem and barb curves. SUV is the UV for the stem. And BUV is the UV for a tiled barbule texture. Feather data has two inputs, curves and skin data. For each input curve, a feather will be generated. And each feather will inherit the data it finds on the closest point of the skin input. If you check the parameter names on the feather data, you can add them as attributes on the skin input to override them. Here, I'm overriding barb count and noise scale. There are also two outputs, feather and data. Feather is the generated feather, and data is all the data used to generate the feather, stored on a point. You can see all the attributes here. If we plug this data into another feather data, you can see all the parameters get overwritten. Here is a little example of what can be done with the feather data node. This concludes the overview of feather data.